Firstly, manganese is a silver-grey transition metal. Manganese is hard, it's brittle, it tarnishes slowly in air and it rusts like iron when placed in water containing dissolved oxygen. This brings me to talk about the chemical properties of manganese. The oxidation states of manganese ranges from 0 to +7. However, the most common oxidation state of manganese is either +2 or +4, which explains why manganese is best observed at either a divalent or a tetravalent state. Manganese compounds which have like a valence oxidation state of +7 are used as best oxidizing agents. Now, manganese is chemically reactive, which means that when it's placed in water, it will decompose. Alternatively, when it's placed in dilute mineral acids, it would dissolve. Now, this table shows the physical properties of manganese. As you can see, the melting point, the boiling point, the molar mass, the density at room temperature, and it also shows the two forms of electromagnetic configurations of manganese. Now, to talk about the magnetic properties of manganese metal and its common ions are paramagnetic. Now, paramagnetism is a form of magnetism where certain objects are attracted by the externally applied magnetic field. However, with a particular treatment, that is to alter the magnetic fields of manganese can become ferromagnetic. Now, ferromagnetic is a term which is used for objects that are attracted to either of the poles of the magnet. To briefly talk about the spectral properties of manganese, firstly, here is the emission and absorption spectra of manganese. Manganese has a wavelength of 297 nanometers. 297 nanometers lies in the, as it can be seen, that 297 nanometers lies in the ultraviolet of the electromagnetic spectrum, which means that the emission and absorption of manganese will occur in the ultraviolet section of the electromagnetic spectrum.
Manganese is the natural occurring metal that is found in external and internal environments. It's abundant in the S crust that through erosion and leaching can cause different concentrations of manganese in the soil, the atmosphere, and different types of water, such as river water, seawater, and groundwater, which in comparison has the highest concentration of all. It's also found in the human and animal body as a nutrition component for the amino acids, the enzymes, metabolism, and other organs within the body. However, high concentration of manganese can cause catastrophic results and be lethal to the health system, for it can cause mutations, reproductive disorders, neurotoxicity, and other health issues. The consumption of water containing more than 10 milligrams of manganese can cause toxicity poisoning in the human body. This graph displays an average intake for both genders and age group.
High concentrations of manganese ions in water increases the bacteria growth, given the energy to produce slime. As a result, the pipelines are blocked and manganese dioxide is formed. Alternatively, in low concentrations of oxidized manganese can form brown stains when they're in contact with other objects.
There are four main methods that are used for the metal detection of the trace element manganese. Method 1 is the atomic absorption spectrometric chelation extraction that detects manganese in water and brines if the sample contains 100 micrograms per litre or more, in which the chelation extraction requiring the water sample to be included. Method 2 is the graphite furnace atomic absorption spectrometric. This method requires that the sample is placed on a graphite platform and a metric modifier is placed. It is then evaporated and atomized at high temperatures. Method 3 is the flame atomic absorption spectroscopy. This method is used to measure the metal concentration of specific heavy metals that the machinery vaporizes the substances and then absorbs the frequency of light. A lab experiment was performed to analyze the concentration of calcium ions in the hard and soft water samples. Ion exchange resin was used to remove the calcium ions in order to obtain soft water. Results are shown here. The fourth method is the most commonly used method of determining manganese at present because the procedure is very simple It is fast and highly sensitive, and this is known as the atomic emissions spectra, or better known as the flame test. This is when a metal is added to a flame, causing combustion reactions where the electron is high in the orbital, releasing energy to form light.
In phosphate treatment, the phosphate delays the precipitation of oxidized manganese. In phosphate treatment, polyphosphate is an excellent source of bacteria. Polyphosphate tend to break down into orthophosphate, which helps to prevent the manganese deposits. While second one is removal by ion exchange. Ion exchange by home software may also remove manganese. If the water has not been exposed to the oxygen, the resin in the softener will remove the manganese ions from the water. And then we can do it by only oxidation also. And first one is oxidation using aeration. Manganese is easily oxidized by atmospheric oxygen. Aeration provides the dissolved oxygen needed to convert the manganese from the manganese forms to their unstable oxidized manganic forms. As well as we can do oxidation by chlorine and permanganate. And the last one is the filtration. Filtration to remove insoluble manganese material is used as the final step in manganese treatment.